Excuse me, bless me. All right. So here it says use a calculator to complete the table. So this is just a visual to kind of explain what's happening. But before we jump into the calculator, we're going to practice mental factoring. Is that cool? And the reason why I know I can do mental factoring is because my leading coefficient for both of these is a 1. Your degree is 2, but your leading coefficient is a 1, right? So therefore, mental factoring is back at play, right? So I'm asking myself what multiplies to give me negative 12, but adds to give me negative 1. So what multiplies to give me negative 12? What kind of 4 and 3?
Negative 4 times 3.
Perfect. X minus 4 and x plus 3. Yeah?
Yeah. No, that's 3.
Okay, you're the one that told me.
Wait, so,
Because negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1.
Okay.
Okay. What multiplies to give me negative 8, but adds to give me negative 2? Negative 4 and positive 2. Oh, there's a hole. So this is going to lead to, I simplify, right? So we have x plus 3 over 2 over x plus 2. And this is with a hole where? At x equals 4. Because 4 minus 4 would make it 0. We did that completely without a graph. Was it terrible? No, it wasn't. Y'all are so dramatic. Okay.
So
I can do that, but like I feel like if I look at that, I think all this I wouldn't know.
That's what the learning is part is. That's why we have practice. Now you see why you have so many problems. Practice it. If you don't practice it, you're gonna be like, no. Still, either way. All right, so here we go. We're gonna look at the graph, just a little more hands-on so that you can see when we're filling in the table how these values are approaching. Okay, so to kind of get a clear understanding of our limits, I'm going to turn on Sylvie and I'm going to clear her from my college algebra knowledge. We are. You're so smart. All right, so I'm going to put this in. I'm going to put in my simplify function. Got it? I'm putting in x plus 3 divided by x plus 2. Okay, the reason why I'm putting this in is because I'm going to show you that we have to state that as a whole, because when I put it in like this, guess what? It's not going to show me the whole. I'll hit graph. It's not going to show me the whole in my graph. All right. I don't know what you did. Did I not put that right?
Oh. Did you do that?
I told you clear your calculator first. Are we good? Second plus 712. All right. So now we're here. The beauty of putting in like this, I can find exactly where my hole is, but we're going to do that when we fill in the table. To be able to fill in table values of what we want, we're going to change our table setting. Do we remember how to change our table settings? Anyone? Go to table set. How do I get the table set? Second window. We're going to go to second window. And we're going to change our independent from auto to ask. And what this allows us to do is now we're going to literally just type in negative 500, negative 100, negative. Fractions. I'm going to put my mode into 3 decimal places. Okay. And now when I go to the table, I'm going to put in my values. So the first up is negative 500, right? I type in negative 500 and it tells me that negative 500 is
What is it?
998. Now I'm going to do negative 100. I'm going to put in negative 2 and 1 thousandths, negative 1 and 999 thousandths. I'm gonna put in 0. What else did it want me to do? 3 and 99 hundredths. 4. What else did I need?
4.001.
4.001.
Then 100 and 500.
Then 100.
Mhm.
And then 500. Oh, I wrote 50.
It's still giving me like, fractions.
Oh.
Can you put in the, I don't know.
Did you use the fraction button when you put in your function? That's why. Because the updated calculator assumes if you put in a fraction, you want a fraction as your answer. It's a thing. I don't know. That's why I stick to how I learned and just put everything in parentheses. But the numbers are right here, lady. You know what you're doing. It's just that the calculator is programmed. If you put in a fraction, it thinks you want a fraction in return. All right, so we have these values. Yes.
So how put the negative 500 gave like a fraction? Yeah, they have fractions. I don't know why.
Like what we just said.
Yeah, they will pay attention.
What else
I
are
feel it.
Carlos?
I'm like 3 steps behind them.
I can come at
When you're putting it into y equals, you have to put in a factor from not the actual fraction, right? A fraction, because it'll be fractions. If you put a fraction in there.
So it's supposed to be x plus 3 divided.
Yeah, so like you see how right here, Carlos, I wrote mine in parentheses
Oh.
because I wrote it without a fraction. Like I didn't hit second variable button. I just wrote it.
Okay, so it's a fraction, the parentheses. So doing it.
Yes, so the parentheses, you protect your numerator, your denominator. You're welcome. But with y'all's new fancy updated skinny calculators, they made these weird algorithms that automatically go for it. I don't know. What was the value at 4? 76 is gonna be. Is that not it? I got negative 999.
Oh, I don't know that.
Oh, yes. And then this is a whole, so I'm gonna make note that it's a whole. And the value of the whole would have been 76. And then we have 1.167. Then I had 1.010 and 1.002.
Oh, this is cool.
These are my discontinuities. Does that make sense?
Yes.
The things in my graph that makes it not continuous. So when you're describing, so this is asking for a specific value. So it says as x goes to negative 500, so as x is heading towards negative 500, what is happening to my numbers? They're getting smaller. They're getting closer to what?
I mean, 1.
To 1. They're getting closer to 1, right? These are getting bigger. This was a negative 999. This was a really low number. Why is it getting closer to 1? Because you have a horizontal asymptote. Look at your things. You see that? Look at that magic. Yeah. Okay. Now on the other end, as we are getting, we're getting smaller here, right? So we're getting smaller and smaller, but we're still getting closer to 1. Why are we getting closer to 1? What is our reason? What kind of asymptote? We have a horizontal asymptote. At y equals 1. Does that make sense? So no matter where it's going, our values are going to try to get closer and closer to 1.
What'd you get? Negative 999.
When I typed in negative 2.001, that's what it was. Like negative 999.
Yeah.
Yeah.
That's really.
Why is there a hole at 1 or at 7/6?
There's a hole because what did we say our hole is at? There we go.
From the x minus.
If I plug 4 in, what's 4 plus 3?
7.
What's 4 plus 2? So my hole is at 7/6.
Bro, it's flabbergasted.
I know, math is mathing. What? I know, crazy. All right, now, this is talking about around our asymptote behavior. So our asymptote is right here, correct? So when we're coming from the left, where are these numbers? What is this number doing? It's going to keep going towards smaller and smaller negative numbers, right? So it's heading towards negative infinity. So here's our asymptote coming from the right of our asymptote, where we jump from 3.99 all the way to -19. It's at 1001. So what are these values doing? They are increasing. We went right, coming from the right. So then they're heading towards positive infinity. And why are they doing this? Because what is x? What is -2? An undefined, and it's undefined because it's what? A vertical asymptote. It is a vertical asymptote. I wonder if people outside of Texas listen to my video like, she is just so country.
She what?
I don't know.
A vertical asymptote.
Look here, guys. Look here. How dare you guys not trust in my viewership? You don't know my life.
I don't even read that right.
You don't know. I may be, Ivy. I may be.
You would know.
Yeah.
Whatever. It doesn't matter. All right. So that is how using a table can sometimes, if you can't visually see it from a graph, do you see what it's approaching from a table a little bit better? A little, somewhat. All right, guys, we tried to work really fast. We didn't make it. So we will finish this part. And then number 7 was for you to work on in your group, and we will do that tomorrow. Tomorrow. Is my phone ringing? Yeah. Can someone answer the phone?